You know what kills me about the 2JZ? It's not that it's indestructible. It's that Toyota built it that way completely by accident. They weren't trying to create the most overbuilt engine in automotive history. They were just trying to make a reliable luxury car motor that wouldn't embarrass them in their new Lexus showrooms. And somehow, through a perfect storm of paranoid engineering, ridiculous safety margins, and what I can only describe as institutional anxiety about warranty claims, they accidentally created an engine that laughs at 4-digit horsepower numbers. I mean, come on. The thing was supposed to power executive sedans, not 1,000-horsepower Supras that launch so hard they alter the Earth's rotation. Toyota's engineers would probably have a collective aneurysm if they saw what people do to these engines today. Twin turbos the size of watermelons, boost pressures that could inflate the Hindenburg, power levels that make dynos cry. And the 2JZ just sits there asking for more. But here's where it gets interesting. The story of why this engine is so stupidly strong starts way before the first 2JZ rolled off the production line in 1991. It starts with Toyota getting their teeth kicked in by Nissan. See, back in the late 80s, Nissan had this little engine called the RB26DTT. You've probably heard of it. Godzilla's heartbeat. The thing that powered the R32 GTR to victory after victory. Toyota watched their rival dominate with this twin-turbo inline-six and thought, we need one of those. Except being Toyota, they didn't just want to match Nissan. They wanted to humiliate them. So they assembled what I can only imagine was the most overqualified team of engineers in automotive history. These weren't your average engine designers. These were the guys who'd spent the previous decade working on Formula One programs and Group A rally engines, people who thought normal passenger car engineering was beneath them. And Toyota basically gave them a blank check and said, build us something that makes the RB26 look like a lawnmower engine. The first thing they did was completely overthink the block design while everyone else was using cast iron blocks because that's what you did in 1990. Toyota decided to get fancy. They went with a cast iron block, sure, but not just any cast iron. They specified a particular grade of iron with a tensile strength that was honestly overkill for a street engine. We're talking about iron so dense and uniform that even today, 30 years later, machine shops regularly find original 2JZ blocks that measure perfectly true despite having been beaten on for decades. The block itself is a work of art disguised as a chunk of metal. 7 main bearings instead of the usual 4 or 5, each main cap secured with not 2 but 4 bolts, and not just any bolts. These were specially heat-treated pieces that could probably hold the Golden Gate Bridge together. The main bearing cradle is essentially one massive girdle that ties everything together like a boxer's abs. It's so overbuilt that tuners regularly push 800 horsepower through stock bottom ends without even checking bearing clearances. But wait, there's more. The cylinder walls. Oh man, the cylinder walls. Toyota didn't just make them thick, they made them stupid thick. We're talking about walls so massive that you can bore these engines out multiple times and still have more material left than most engines start with. The cooling passages around each cylinder are designed with this obsessive attention to uniform temperature distribution that borders on the pathological. Each cylinder stays within 2 degrees of its neighbors even under sustained wide-open throttle runs. Now let's talk about the head, because this is where things get properly mental. Toyota looked at every other inline-six head design and decided they were all wrong. Instead of the traditional exhaust on one side, intake on the other layout that literally everyone else used, they went with a square port design with nearly vertical intake ports. Sounds simple, right? Wrong. This design required them to completely rethink the entire valve train geometry. The cam angles, the rocker arm ratios, everything had to be recalculated from scratch. The result was a head that flows like a river in flood season. Stock 2JZ head supports 600 horsepower without any porting. That's not a typo, 600. From a head designed for a luxury sedan, most performance engines need extensive headwork to support that kind of power. The 2JZ does it with the head Toyota bolted on at the factory. The combustion chambers are these perfect little hemispheres that promote incredibly uniform flame propagation. The spark plug placement, the valve angles, even the surface finish of the chambers, everything is optimized for efficiency at levels that shouldn't exist in mass production. And the cams, sweet, merciful crap, the cams. Toyota specified billet steel camshafts when everyone else was using cast pieces. Billet steel. For a production engine, do you have any idea how expensive that is? These cams are so overbuilt that drag racers spinning these engines to 9,000 RPM report zero cam deflection. Zero. The valve springs are similarly over-engineered, double springs with titanium retainers from the factory. This is stuff that was exotic race technology in 1991, and Toyota just casually threw it into their production engines. But perhaps the most insane aspect of the 2JZ's strength comes from something most people never even think about: the oiling system. Toyota's engineers approached oil flow the way NASA approaches rocket fuel management. The oil pump is this massive gear-driven unit that could probably supply a small apartment building with water pressure. It's so overbuilt that at high RPM, it actually needs a bypass system to prevent overpressurizing the entire system. The oil passages throughout the block are huge, smooth-walled galleries that ensure every bearing, every journal, every wear surface is constantly bathed in a river of oil. The oil squirters are another example of Toyota's belt and suspenders engineering philosophy. These are little nozzles that spray oil directly onto the undersides of the pistons for cooling. Lots of engines have them. But Toyota's implementation is different. The squirters in a 2JZ are positioned and angled with this obsessive precision that ensures complete coverage of the piston crown under all operating conditions. They even accounted for oil stream deflection at different RPMs. Who does that? Speaking of pistons, let's discuss why 2JZ pistons are basically indestructible little nuggets of aluminum. Toyota didn't just specify forged pistons, which would have been impressive enough for a production engine in 1991. They specified oil-cooled forged pistons with a specific aluminum alloy that maintains its strength at temperatures that would turn normal pistons into puddles. The ring lands are thick enough to park a car on. The pin bosses are reinforced with extra material in exactly the places where stress concentrations occur. These pistons regularly handle boost pressures that would turn normal pistons into modern art installations. The connecting rods deserve their own documentary. These aren't just strong, they're comically overbuilt. Toyota specified forged steel rods with a cross-section that wouldn't look out of place in a top-fuel dragster. The rod bolts alone are rated for something like 12,000 pounds of tension. Each rod weighs almost as much as 2 rods from comparable engines. But here's the genius part. Toyota balanced them all to within half a gram of each other, so despite being massive, they don't create any unwanted harmonics or vibrations. Now you're probably thinking, surely Toyota must have cheaped out somewhere. What about the crankshaft? Nope. The 2JZ crank is a fully counterweighted forged steel unit that's been precision balanced and heat treated to strengths that make tool steel jealous. The journal overlap is massive, meaning there's tons of material where the rod and main journals meet. This is the area where cranks typically fail under extreme power, and Toyota just made it stupid strong. Tuners have pushed 2,000 horsepower through stock 2JZ cranks. 2,000. The crank Toyota designed for a car that originally made 220 horsepower. The head gasket situation's equally ridiculous. While everyone else was using composite gaskets or basic multi-layer steel designs, Toyota developed this exotic multi-layer steel gasket with special coatings and embossments that create multiple sealing zones around each cylinder. The gasket's so good that it's become the go-to solution for other engines when built for high boost. MLS gaskets are common now, but in 1991, this was space-age technology. But here's what really sets the 2JZ apart from every other engine of its era: the systems integration. Toyota didn't just build strong individual components. They built components that work together in perfect harmony. The block supports the head perfectly. The head gasket seals against both perfectly. The rotating assembly is balanced so well that these engines run glass smooth at any RPM. Everything is designed with this holistic approach where each component supports and reinforces the others. The cooling system is a perfect example. Toyota didn't just slap a radiator on it and call it a day. They designed a cooling system with massive overcapacity, huge water passages, and a water pump that flows like Niagara Falls. The thermostat housing, the radiator cap pressure, even the coolant passage shapes, everything is optimized for maximum heat rejection. This is why you can run a 2JZ at 800 horsepower on a stock cooling system and maintain stable temperatures. Even the accessories are overbuilt. The alternator is rated for way more current than the engine could ever need. The power steering pump is strong enough to steer a bus. The AC compressor could probably cool a small house. Toyota approached every single component with the philosophy that it should last the lifetime of the car without any maintenance beyond fluid changes. This brings us to the elephant in the room, the twins. The 2JZ GTE, the twin-turbo variant that powered the Supra Turbo. This is where Toyota's engineering paranoia reached its absolute peak. They didn't just bolt some turbos onto their already overbuilt engine. They redesigned half the engine to handle boost pressure. The compression ratio was dropped to 8.5.1, which is incredibly conservative, even by early 90s turbo standards. The pistons were redesigned with even thicker ringlands and deeper valve reliefs. The head gasket got even more robust. Oil squirters were added. The cooling system was upgraded, and the turbos themselves were these sequential twin units that were small enough to minimize lag, but robust enough to handle twice their rated boost pressure. The sequential turbo system deserves special mention because it's both brilliant and completely insane. One turbo operates at low RPM for response, then the second one comes online at higher RPM for power. The system is controlled by this complex arrangement of vacuum lines and solenoids that looks like someone's fever dream. It's complicated, sure, but when it works, it delivers this perfectly linear power delivery that feels like naturally aspirated response with turbo power. But here's the thing that really showcases Toyota's engineering prowess. The normally aspirated 2JZ GE is almost as strong as the turbo version. They could have cheaped out on the non-turbo variant, used cast pistons, maybe a cast crank, definitely thinner cylinder walls. But they didn't. The 2JZ GE got forged internals, the same massive cylinder walls, the same overbuilt oiling system. The only real differences were the compression ratio and the absence of oil squirters. This means you can take a junkyard 2JZ GE, slap a turbo on it, and immediately make 500 horsepower without opening the engine. The transmission options Toyota paired with the 2JZ were equally overbuilt. The Getrag V160 6-speed manual that came in the Turbo Supra is widely regarded as one of the strongest manual transmissions ever put in a production car. It regularly handles 1,000 horsepower with just a clutch upgrade. The automatic option, the A340E, might be even more impressive. It's a 4-speed slush box that somehow handles massive power levels that would grenades most modern dual-clutch transmissions. Now let's address what you're probably thinking. If the 2JZ is so perfect, why did Toyota stop making it? The answer is both simple and tragic: emissions and economics. By the late 90s, emissions regulations were getting stricter, and the 2JZ's design made it increasingly difficult to meet them. The engine was also expensive to produce. All those forged internals, the complex head design, the sequential turbo system, it all cost money. Toyota could build 3 economy car engines for the price of one 2JZ, plus the market was changing. The sports car segment was shrinking, killed by SUVs and changing consumer preferences. Insurance rates for turbo cars were astronomical. Gas prices were rising. The writing was on the wall. Toyota discontinued the 2JZ in 2002, replacing it with smaller, more efficient engines that made similar power with half the displacement and a third of the production cost. But here's where the story gets interesting. The 2JZ's retirement from production was actually the beginning of its legend. As these engines entered the used market, tuners discovered something extraordinary. All that overbuilding that seemed excessive for a stock engine made perfect sense when you started adding power. A lot of power. The first tuners to really push 2JZs were the drag racers. They discovered you could run 30 pounds of boost on a stock bottom end. 30 pounds. That's enough pressure to inflate a car tire. The engine would just shrug and ask for more. Then they discovered you could rev them to 8,000 RPM without any valve float. Then 9,000. With upgraded valve springs, the power levels kept climbing. 600 horsepower, 800, 1,000, 1,500, 2,000, and the 2JZ just kept taking it. What makes this even more insane is the simplicity of these builds. You don't need exotic materials or NASA-grade engineering to make big power with a 2JZ. Bigger turbos, more fuel, a standalone ECU, and you're making 4-digit horsepower. Compare that to building a Honda K-Series or a Mitsubishi 4G63 to the same power level. You need forged everything, probably a sleeve block, definitely upgraded head studs, and extensive machine work. The 2JZ, stock block, stock crank, stock rods, maybe some ARP head studs if you're being cautious. The drifting. Community discovered the 2JZ around the same time and fell in love for different reasons. The engine's smooth power delivery and bulletproof reliability made it perfect for the sustained abuse of competitive drifting. You could bang it off the limiter for an entire run, transition after transition, and it would just keep singing its inline six song without missing a beat. The sound. We need to talk about the sound. The 2JZ has this distinctive, hollow, almost metallic wail that's instantly recognizable. It's not the raspy scream of a Honda or the rumble of a V8 or the boxer burble of a Subaru. It's this smooth, almost turbine-like sound that gets more intense as the revs climb. At full boost, it sounds like barely contained violence, like some ancient god of speed clearing its throat. But perhaps the most impressive thing about the 2JZ is its consistency. Every 2JZ seems to make the same power with the same modifications. You can take 10 different 2JZ engines, give them the same turbo setup, and they'll all make within 20 horsepower of each other. This consistency is unheard of in the tuning world, where engine-to-engine variation can be significant. It speaks to the quality of Toyota's manufacturing processes and the robustness of the design. The aftermarket support for the 2JZ is now so extensive it's almost comical. You can build an entire 2JZ from aftermarket parts if you wanted to. Billet blocks, billet heads, custom cranks, rods, pistons, cams, everything. There are companies whose entire business model is based on making parts for an engine that's been out of production for 2 decades. That's how you know you've created something special. The 2JZ has also become a popular swap candidate for, well, everything. People put them in BMWs, Nissans, Mazdas, even American muscle cars. There's something perversely satisfying about dropping a 2JZ into a classic Mustang and watching it destroy coyote-swapped cars at half the displacement. The engine is so versatile that it works in almost any application: drag racing, drifting, time attack, street cars, even boats. Yes, boats. There are people running 2JZs in offshore racing boats. The longevity of these engines is the stuff of legend. There are 2JZs with 300,000 miles on them still making stock power. There are 1,000 horsepower 2JZs that have been beaten on for years without a rebuild. The engines just don't wear out in any normal sense. They're like the automotive equivalent of a Rolex, getting better with age and abuse. The influence of the 2JZ on modern engine design can't be overstated. BMW's B58, widely regarded as one of the best modern Turbo 6s, is basically a German interpretation of the 2JZ formula. Closed deck block, forged internals, overbuilt bottom end. Even Toyota's own replacement engines show 2JZ DNA, though none have matched its legendary strength. But here's what really gets me about the 2JZ. It represents a moment in time that will never happen again. A moment when a conservative company accidentally built something so far beyond what was necessary that it became immortal. Today's engines are designed with computer simulations that optimize every gram of material. They're strong enough for their intended purpose and not an ounce more. The idea of accidentally overbuilding something to the extent of the 2JZ is impossible in modern engineering. The 2JZ was also the last of the truly mechanical performance engines. Yes, it has electronics, but they're simple electronics. The engine doesn't need 47 sensors and a PhD in computer science to run properly. You can tune it with a laptop and basic software. You can diagnose problems with a multimeter and common sense. Try doing that with a modern direct injection, variable valve, timing, electronically controlled everything engine. There's something beautiful about the 2JZ's simplicity. It's just an inline six with turbos, no hybrid systems, no cylinder deactivation, no direct injection, no variable compression ratios, just 6 cylinders in a row making power the old-fashioned way. It's honest in a way that modern engines can't be. The cultural impact of the 2JZ extends far beyond just car enthusiasts. It's become a symbol of Japanese engineering excellence, mentioned in the same breath as the Nissan GTR, Honda NSX, and Mazda RX-7. It's inspired countless memes, videos, and internet discussions. The phrase 2JZ the engine, no shit from the original Fast and Furious movie, has become part of automotive folklore. The racing success of 2JZ-powered cars is equally impressive. From drag strips to road courses, 2JZs have won everything. They've powered cars to 6-second quarter miles, dominated time attack series, won drift championships. The engine's versatility means it's competitive in almost any form of motorsport. What's particularly interesting is how the 2JZ has aged compared to its contemporaries. The RB26 is also legendary, but it has well-known weak points like oil pump failures and thin cylinder walls. The 4G63 is strong but needs extensive work to reach 2JZ power levels. American V8s of the era are laughably weak by comparison. The 2JZ stands alone as the engine that was built right the first time. The economics of 2JZ ownership are fascinating too. These engines have actually appreciated in value. A good condition 2JZ GTE can cost more now than it did new. Even high mileage examples command premium prices. It's created this weird situation where people are hoarding 2JZs like they're gold bars, waiting for prices to climb even higher. The future of the 2JZ is assured by its past. As long as people want to go fast, there will be a market for these engines. They're being rebuilt, refreshed, and upgraded with modern technology. Billet blocks rated for 3,000 horsepower. Billet heads that flow enough air to inflate a blimp. The evolution continues, even though production stopped 2 decades ago. Sometimes I wonder what would have happened if Toyota had continued developing the 2JZ. Imagine a direct injected 2JZ with variable valve timing and modern engine management. It would probably make 500 horsepower naturally aspirated and be capable of 2,000 with turbos while meeting modern emission standards. But then again, maybe it's better that it ended when it did. The 2JZ remains frozen in time as the perfect performance engine, untainted by modern compromises. The real tragedy is that we'll never see anything like the 2JZ again. Modern manufacturers are too smart, too efficient, too optimized, accidentally build something so over-engineered. Everything is calculated to the nth degree. Every component is exactly as strong as it needs to be and not a bit more. The era of accidental excellence is over, but maybe that's what makes the 2JZ so special. It's not just an engine, it's a reminder of what happens when engineers are allowed to build without compromise, when quality matters more than quarterly earnings, when durability is more important than planned obsolescence. The 2JZ is proof that sometimes, just sometimes, corporations accidentally create something perfect. And that's why the 2JZ is indestructible. Not because Toyota tried to build an indestructible engine, but because they tried to build a reliable one and massively overshot the mark. They brought a nuclear bomb to a knife fight. They built a bank vault when all they needed was a jewelry box. They created a monster and dressed it up in a suit and tie. The 2JZ will outlive us all, long after the last electric car has recycled its batteries. There will still be 2JZs making 4-digit horsepower and terrifying passengers. They'll become the mechanical equivalent of classical music, appreciated by future generations who'll wonder how primitive humans managed to build something so perfect with such crude tools. So next time you hear that distinctive inline-six wail, that metallic shriek of boost and violence, remember, you're not just hearing an engine. You're hearing the last roar of an era when engineers were allowed to dream, when building the best was more important than building the cheapest, when a company could accidentally create a legend just by trying to avoid warranty claims. The 2J isn't just indestructible, it's immortal.